Good morning. So let us continue our lesson. Analytic geometry, equations of straight lines. So now I'm going to start today's lesson by one question. If I give you two equations for two straight lines, without graphing them, how do you understand if the lines are parallel or not? For example, if I give you this equation, first of all, hopefully you realize that this is an equation for a straight line, yes? And if I give you another equation like this, do you think if I draw them in one coordinate system, they become parallel? If yes, why? If no, why? Yes?
No, since the slope or k value is not equal.
They are not equal, yes? Because the k value, so you know that if two lines are parallel, do you remember? So if I have two lines parallel like this, then if I ask you if this angle is alpha and if this angle is beta, and if these two lines are parallel, so let me call this line number 1, line number 2. So I hope that you agree with me that L1 is parallel. This is the symbol we use for being parallel. L1 is parallel to L2 if and only if. What is this relation between these angles alpha and beta? If they are parallel, hopefully you agree with me, the sizes of angles alpha and beta are equal, yes? And if two sizes are actually equal, then it means that tangent of alpha is also equal to tangent of beta. But if I ask you what is tangent of alpha is just the slope of this line. So this becomes the slope of the first line is equal to the slope of the second line. Tangent of alpha is the slope of the first line. Tangent of beta is the slope of the second line. So this means that these two are the same. Yes? So now if I ask you what is the k value here, you would say the k value is 2. And if I ask you what is the k value here, you would say that the k value is 3. And because these k values are not the same, so they cannot be parallel. Yes? So that's correct. But what about the vertical lines? For example, if I give you this line, I hope that you know that this is a vertical line, yes? Because there is only x in it. And then if I give you this line, are these two lines parallel? Here I cannot compare the k values. Of course the k value for this one is 2, but what the k value of this one is, that is undefined. But we really don't need to be worried about that because we know that this line is a vertical line and this line is an inclined line, so they cannot be parallel. So that's not an obstacle in front of us. Even if I have a vertical line, I immediately realize when they are parallel, when they are not. So we would say that two lines are parallel if and only if both of them are vertical or the k values are the same. Other than that, the lines cannot be parallel. Any question? Is that understandable? Yes? Okay. So let me give you a simple example, solve it together. So example, the lines, I always tell you that, here I always mean straight lines, yes? The lines y equals to 4x plus 3 and 2y minus mx equals to x minus 2 are parallel. Determine m. Yes? So I have given you two lines. Hopefully, this is very easy. This is the k form of a straight line. But that is a little bit not organized. But how do you know that this should be a line? Because I have powers of 1 for x and y, and I do not have a mixture of x and y as a product. So that is definitely a line that can be written as in the general form of a straight line. So this is exactly comparable to the K form. Do you remember what was the K form? Kx plus m. So by looking here, I see that K value is 4, m value is 3. This is actually just, if you want, let me change it to another letter. Let me make it A. And then I would say determine A. So don't get confused this m with that m there. Okay, so how should I solve this problem? I have two lines, and I want to make them parallel. So it means that the slopes should be the same. If I ask you what is the slope of this one, it is easy to read. So the slope is just simply, let me write it the slope of the first line. Put a 1 there. This is the first line. This is 4. But for finding the slope of this one, you have to do a little bit of work. You have to change the form of this equation of the line into the K form, and then you can read the x coefficient. That number will be actually your slope. So what do I do? For making an equation in the K form, I have to make y alone. So what I do, I start from my equation, 2y minus ax equals to x minus 2. I move minus ax to the right. My goal is to make y alone. It becomes positive ax, but there are also another x there, and then I have minus 2. Okay, then I divide by 2 to make y alone. There are 3 terms to divide by 2 here. So this becomes a over 2x. This becomes 1/2 x, and then this becomes minus 1. Okay, now if I ask you, by looking at this equation, can you tell me what the K value is? Yes, Ali?
Is it a over 2 plus 1/2?
Yes, exactly, because you have two x's in 2 places, yes? If you want to read the K value, you need to make it as a K form. In the K form, I have x in 1 place, not 2 places here. So then this means that I have to continue and write it as what Ali said. I can factor x out. So then what is left for me is a over 2 plus 1 over 2x. And then I have minus 1. Now, this is good. If I ask you what is the K value of this line, then you can read it. So let me write K number 2. K value for the second one. Okay, what is that one? Is the coefficient of x, which is a over 2 plus 1 over 2. So the K value of the first line is 4. The K value of the second line is a over 2 plus 1 over 2. But I am demanding to determine a so that these two lines become parallel. So L1, let me call it L1, equals to, so being parallel to L2 means that K2 should be equal, K1 should be equal to K2. And then this is easy to solve, yes? So what I do, I take this one, I take 4 instead of K1. On the right hand side, instead of K2, I put this value. And then you see that this is only, there is only one single unknown for me. I need to solve it. For me, it's better to get rid of fractions as soon as possible. So I multiply everything by 2, it becomes 8. This becomes a, this becomes 1. And then what does it mean? N is 7. That is what I have to provide. So it means that if I choose a to be 7, then this becomes a line which will be parallel to the other line. Any questions? Okay, another example. Determine an equation for the line that passes through the point A with coordinates -1 and -2 and is parallel to the line 2x minus 3y plus 7 equals to 0. Yeah, this is a very simple but important example, so let me equip it with the star. Determine an equation for the line, I mean a straight line, that passes through that particular point, -1 and -2, and is parallel to the line with this equation. So what I'm supposed to do, if you want to write an equation for the line, you need to know a point, which we know, and we need to know the k-value, which apparently we don't know, but using this idea we can immediately find that, yes? So, to write an equation, I need this formula. Do you remember 1-point formula? This is the 1-point formula. X node and y node are the coordinates of one point on the line. No matter which point, you just need 1 point. But you also need the k-value. But this line, according to the problem, is supposed to be parallel to this line. So this means that if I find the k-value of this line, this will be also the same number for the k-value of the line that I'm supposed to write its equation, yes? That's it. That's very simple now. So it means that if you want to imagine, you see, for example, assume that this is this line, but the point A is somewhere here, for example. I want to draw a line that passes through this point and parallel to that one. What I'm saying is that I need the k-value of this. But even though this line is different from this line, because they are supposed to be parallel, the k-values are the same. So if I find the k-value of this, this will help me. That can be the same value for the k-value of that one. So here, I calculate the k-value. But for calculating the k-value, I need the k4. So I have to make y alone. So I move these two terms to the right. And then divide by -3. So then y becomes alone. This becomes +2/3x, +7/3. So this number is the k-value of this solid line, which is equal to the k-value of this dotted line that I am supposed to write its equation, yes? And that is it. So I would write this y minus y node, which is this number. K-value is 2/3. And then x minus x node, which is -1. And that is the equation that you are supposed to answer. But let me simplify that a little bit. So then it becomes y plus 2. It becomes 2/3 of x plus 1. I want to make y alone if I want to write the k4. I move 2 to the other side. I multiply 2/3 in. It becomes 2/3. And then 2 moving to the right becomes -2. And then you can simplify it a little bit, yes? Because 2/3 minus 2 is -4/3. This is an equation for the line that passes through that point and is parallel to the given line. Is that understandable? Okay, let me give one more example. A minus 4 and 1, B 0 and 5, and C 4 and minus 3 be vertices of the triangle, either vertices of the triangle ABC. If D and E are the midpoints of the sides AB and AC respectively, show that DE is parallel to BC and is half its size, is its length. This is completely generic. We will study that later. That this is not only true for this particular triangle, but for any other triangles. We will study that from pure geometrical points of view later. But for the time being, let us just solve it analytically. This is a very simple exercise. So, for solving these kinds of problems, of course, you can draw a very precise shape figure for yourself, but I really don't want you to do that. You just go to a scratch paper to analyze the problem and try to find the important points and use them to solve the problem. I mean that don't spend so much time to draw a very precise picture unless you want to do it yourself. So I would go to a scratch paper. I have a triangle. A, B, C. Yes? Yeah, do not talk please here in the lesson. Hello. Okay, so here I need to find, this is a triangle. I really don't care if that is a precise figure or not. I'm just trying to understand the problem. And this is mentioned D and E are the midpoints of the sides A, B, and AC respectively. So D is the middle of AB, for example, something like here, and then E is in the middle of AC. Yes? And then we are supposed to show that DE is from here to here, automatically becomes parallel to the third line, to the third side. So it means that if you find the midpoints of these two and connect them, the line that you get, the line segment that you get, is definitely parallel to the third side. And interestingly, the size is half of the size of BC. This is not a coincidence. This is always true, but in this case, we want to investigate the truth of this for this particular triangle with these numbers. Okay, but that's very easy, yes? Okay, tell me what to do. The first thing, I want to convince myself that DE is parallel to BC. What I'm supposed to do? Someone else? We just learned, if you want to show that these two, of course they are not lines, but they are part of straight lines, yes? So you can, in your head, you can continue them. Of course, it is clear that this part and this part are parallel if and only if the lines are parallel. And there is only one way to show that the lines are parallel, by comparing the k values. So it means that I need to find the k value of BC and the k-value of DE, and show that these values are the same. Calculating the k-value of BEC is simple. I just need to start with the formula. So for example, I write the k-value and then I put BC here, meaning that this is the k-value for BC. Then the formula is YB minus YC, the difference between Y's divided by the difference between X's, in the same order that I write the numerator. So then let us calculate. Y of B is given is 5, minus Y of C is given to be minus 3, divided by X of B is given to be 0, X of C is given to be 4. And then it becomes positive 8 divided by minus 4. So this means that the k value for the line segment BC is negative 2. Yes? But for finding k value of DE, what I am supposed to do first, because I don't know D, I don't know E yet. But how should I do that then? Yes?
Find the coordinates of the midpoint.
Midpoint, yes? So X of D is the midpoint of AB, so X of D is X of A plus X of B divided by 2. And Y of D is Y of A plus Y of B divided by 2. So what is X of A? Read it from the problem. It's minus 4. What is X of B? Is 0. And then divided by 2 is minus 2. For the Y coordinates the same, 1 and 5. Divided by 2 is 3. So if you ask me what are the coordinates of D, I would say minus 2 and 3. You found that. And now we go to the next one for E. But E is the midpoint of A and C. So if I ask you what is X of E, it's X of A plus X of C divided by 2. X of A is minus 4. X of C is 4. Divided by 2 is 0. Divided by 2 is 0. And we have the same thing for Y of E. So it is Y of A plus Y of C divided by 2. Y of A is 1 plus Y of C is minus 3 divided by 2. It's minus 2 divided by 2 minus 1. So if I ask you what are the coordinates for E, you would tell me 0 and minus 1. Yes? And now what I can do, I can find the k value for DE. If I have done my calculations right, I should be able to get the same number. Let us check. So what is the formula for k of DE? I can write the difference between the y coordinates divided by the difference between x coordinates with the same order that I do in the numerator. But look, what is y of D? Y of D, I got it to be 3. So then it becomes 3 minus. Y of E is negative 1. Y of E is negative 1. X of D is minus 2. And X of E is 0. So the numerator becomes 4 divided by minus 2, which is again minus 2. Yes? Okay, they are the same. So this means that the k value of DE is also minus 2. So then what I say, you need to write it in this way. So we'd say that, okay, k of BC is equal to the k of DE. This then implies that BC is parallel to DE. And that will finalize the first part of the problem. And then I told you that this is not a coincidence. Don't think this is only for this particular triangle. It doesn't matter. Any type of triangles that you have, for example, this triangle, if I take the middle point here, and if I take the middle point here, and if I connect these two middle points, this automatically becomes parallel to the third line. And the length of this one will be half of the length of this one. We will prove this later. Okay, but now we want to show that the length of DE is half of the length of BC. But that is not the new lesson, that is the old lesson. So what I have to do, I need to measure the length of, calculate the length of BC. What was that, do you remember? The distance formula. So it is the square root of the difference between x coordinates squared plus the difference between y coordinates squared. Okay, I have b and c here. So then I put them in this formula. So this becomes square root of x of b is 0, x of c is 4 to the power of 2 plus y of b is 5 minus y of c minus 3 squared. So then this is minus 4 to power 2 positive 16. This is a to power 2 is 64. And if I ask you what is the answer, this becomes the square root of 80. Let us keep it like that. So BC is the square root of 80 length units. Now I have to measure DE as well. DE. So the distance DE is the same. So it becomes the difference between x coordinates squared and the difference between y coordinates squared. Yes? So what is this one now? This becomes square root of x of d. Where is d? D is here. X of d is minus 2. Minus x of e. E is up there. So it is minus 0 to power 2. Y of d is 3. Y of e is minus 1 squared. So then it becomes minus 2 to the power of 2 positive 4. And then this one becomes 4 to power 2 16. The answer is that DE is a square root of 20 length units. Okay, but do you agree that DE is half of BC now by these numbers? We are supposed to show that DE is half of the size of BC. Is it right? You are not allowed to use calculator because calculator gives you approximate values. We want to prove that this is exactly the case. Do you agree that DE is indeed half of BC?
We can simplify them.
How?
For 20 root, we can write it as 4 times 5.
Yeah, but let us simplify this one.
Okay.
Yes, that's completely right. So instead of a square root of 80, I can use the trick that you mentioned. Instead of 80, I write 4 times 20. Yes? And then a square root of 4 is how much? Is 2. So it becomes 2 square root of 20. So then I am done, yes? BC is this number. When I divide it by 2, that 2 and that 2 will be gone, and what is left is a square root of 20, which is this one. So hopefully you agree now that if I divide BC by 2, I will get DE. So that is confirmed, yes? So you just write it yourself there. Okay, but the harder question is that if I give you 2 lines, the equation of 2 lines, how can you understand they are perpendicular? Okay, what is perpendicular? It means that they intersect with a 90-degree angle. So how can I understand that one? That is a harder question, and then we want to understand that today. For example, so let me write the word. So 2 lines are called perpendicular. So perpendicular. And sometimes in a little bit more advanced text you see orthogonal. Yes, but we will use this word. So what does it mean? It means that if I have 2 lines, One of them this one, and the other one, for example, that one. If this angle is 90 degrees, if this line is called L1 and if this line is called L2, here we say that L1 is perpendicular, and that is the symbol that we use, L2. Yes? So that is the meaning of being orthogonal or perpendicular. This means that the angle between these two lines is exactly 90 degrees. Yes? Okay, now my question is that if I give you two equations, one for one straight line and the other one for another straight line, how do you think we can realize by looking at the equations if the lines are perpendicular? One extreme case is very simple. For example, if I give you x equals to 1 and I give you y equals to 3, first of all, I want you to be very quick at it. Do you realize that this is an equation for a line? What type of line? A vertical line. Passing through where? 1. So this is this equation. And y equals to 3 is a horizontal line. Yes? Passing through 3. Are these two lines perpendicular? Yes. So that is easy to answer. If one of them is horizontal, the other one is a vertical one, apparently they are perpendicular. But that is not the question. The question is that if we do not have these extreme cases, then what we can do. For example, if I just write two equations for you on the board, I would say that y equals to 2x minus 1, and I write another one minus a half x plus 5. This is the K form of a straight line. This is the K form of an equation of a straight line. How do you know that if this line is exactly perpendicular to this one or not? You want to discover a method so that by looking at the equations of the lines, we can understand if the lines are perpendicular or not. Answering this is a little bit harder. So, what do you think? Even if you have GeoGebra available, by the way, drawing is not a good idea because might be the deviation from 90 degrees is so small that you cannot detect it with your eyes. That's what I'm saying. You really need to find a method to be able to exactly understand if the lines are perpendicular or not. Okay, think a little bit on it until I'm cleaning the board. It's not that easy.
Vad menar du med K-värdena? K-värdena är 1,5.
Yeah, let us keep it. Okay, let us discover the relation between K values. There is a very nice relation between the K values of the lines that are perpendicular. Of course, not for that extreme case, because vertical lines, the slope of vertical lines are not defined at all. But how should I understand that? Let us consider a scenario like this. So, assume that this is your coordinate system. Okay, so this is the x-axis and that is the y-axis. Let me draw two lines. Now let me be a little bit particular in this case. I want to draw the lines through the origin. You might say that what will happen if they are not passing through the origin, then together we will answer that one as well. But let us now imagine that I have a line that passes through the origin. Yes. So let me call this line L1. Passes through the origin for the time being. And let me have another line which also passes through the origin and it's perpendicular to this red line. Yes. So I will try to Okay, so assume that this is line L2, and I am telling you that, okay, these two lines are perpendicular. These two lines are perpendicular. I want to find a relation between the k value of line L1 and the k value of line L2. Okay? How can I do that? I don't know anything about L1. I know that L1 is neither vertical nor horizontal, and I know that this passes through the origin. The same thing for L2. But now I want to I don't know anything about these angles or whatever, but I know the angle between the lines is 90 degrees. I want to discover a relation between the k values of these two lines. There is no guarantee that there is a connection, but we will see that there is a nice connection between the k values in this case. Okay, here, let me tell you something. Let me pick a random point on L1. Yes? And then let me call it point A. And let me assume that the coordinates of this is A and B. Okay, I am just picking a random point on the red line, and I'm assuming that, okay, the x coordinate is a number, let me give it a name A, and the y coordinate is definitely a number, let me give it the name B. Now my question is that, I hope that you agree with me, that if I ask you what is A in this picture, you would say that I will draw a perpendicular line here, and then from here to here is A, and from here to here is B. Yes? And now I ask you to find the k value in terms of A and B for L1. So k value for L1, what can I do? I can go and choose another point, but I don't need to because I know one point there. Yes, and that is the origin. And that is the reason I ask you to draw it from the origin. So this point O lies on two lines. Forget about the orange line for the time being, concentrate on the red one, and tell me what can I write for k of L1. I can write what? The difference between y coordinates of 2 points on the line. One point is A, one point is the origin. So this becomes y of A minus y of the origin divided by x of A minus x of the origin. But what is y of A? Y of A is B, y of the origin is 0. What is x of A is little a, what is x of the origin is 0. So I really don't need to write zeros, it becomes B over A. So hopefully you agree with me, even if you ask me what is the k value, I still don't know, but at least I know that the k value for L1 is B divided by A. Yes?
Why did we take the coordinates of the origin?
Because I want to find the k value. For finding the k value, I need 2 points. One point, I am assuming that I know, that is A. The other point, of course, I can choose this one, but that is not good because then I am bringing unknowns in, you know. I don't know A and B. If I choose this one, then I will have 2 more unknowns. But if I choose O, it's preferable because then I know that is 0, 0. Yes? Is that understandable? Okay. Now, my question is this. If I can use my fingers to motivate you. So this is the needle of the campus. I put it here and I open it. And I rotate this 90 degrees. Okay? So that I end up on the orange line. So what I do, I will take this and rotate it 90 degrees. Definitely I will end up on the orange line. Yes? Because the angle between these two lines are supposed to be 90. So if I start rotating this about the origin 90 degrees, yes, then I will end up at a point. My question for you is this. Let me write this B. and then I put 2 question marks here. I want you to tell me how can I fill up these question marks. If I give you A and B, and I ask you to find these 2 question marks. If you can answer that, you are done. So what I did, I took this point, I rotated 90 degrees about the origin. Definitely I will end up somewhere on this orange line because they are perpendicular. And I rotated 90 degrees. So then this point has 2 coordinates. Is there any relation between these question marks and these numbers A and B? I don't know what A is, I don't know what B is, but I want to find the connection between question marks and A and B there. Yes, Haya?
This is a guess, but the x-coordinate of B is the y-coordinate of A and vice versa for the
A
y-coordinate.
very small flaw. That's complete 99% correct. Yes, Oscar?
The x is negative.
Negative. Because now you are in the second quadrant, yes? If I ask you what about these numbers, are these positive or negative in this picture? Both of them are positive because we are in the first quadrant. But it is clear that this one is in the second quadrant. In the second quadrant, x is negative even though y is still positive. So exactly right. But how did you come to that conclusion? I want to motivate you about that. So this one, I complete this circle here. I complete this triangle here. I hope that you agree with me because I have just rotated everything 90 degrees. I am not changing any sizes. Yes, this one and that one are actually more or less the same triangle. One of them is the rotated version of the other one. So these 2 triangles are exactly the same size. So this means that, of course my picture is not very good, but if I can do it correctly, this will end up here. So if I ask you what is the size of this, the size of this one and the size of this one are the same. So the size of this one is B. So it means that the x-coordinate of this one is B, but in the negative direction. So this becomes what? Negative. Yes? And then this one from here to here is the y-coordinate of B. But I hope that you agree that the length here and the length here are the same. So this means that this is what?
A.
So that's completely wrong. Now, if I ask you, can you calculate the k value of the orange line? The answer is positive. Because I know the coordinates of B, I know the coordinates of O. So what can I write for k of L2? I can write y of B minus y of O divided by x of B minus x of O. Okay, what is y of B? Is A. What is y of the origin? 0. X of B is negative B. X of the origin is 0. So if I ask you what is k of L2 at the end, you would say A divided by minus B. But instead of putting minus there, I put minus here. A very, very nice relation, yes? I wanted to discover the relation. Of course, this is not good right now because I don't know B, I don't know A. But I can get rid of them simultaneously. How? By multiplying these 2. Yes? So then it means that if I ask you what is KL1 multiplied by KL2, instead of KL1, you'd put B over A, and then you multiply it by KL2, which is minus A over B. But if I ask you what is the result, do I need to give you A and B, or you can just immediately tell me the result without knowing A and B? It's minus 1, regardless of my choice for A and B. So that is why I just took a random point. It doesn't matter which point I choose. So then this one and that one are gone, this one and that one are gone, so it becomes minus 1. And that is exactly the relation I was looking for. So then it means that L1 is perpendicular to L2 under this condition, that the k value of L1 dot the k value of L2 becomes negative 1. That is a result which was not trivial from the beginning, yes? So I want you to know this. two lines are parallel, if the slopes are the same, two lines are perpendicular. If I multiply the slopes, it becomes -1. In that case, the lines are perpendicular. Of course, for those extreme cases that one of them is vertical, one of them is horizontal, we don't even need this because it is very trivial that they are perpendicular. Is that understandable? So now tell me, do you think that these two lines are perpendicular? Yes or no?
Yes.
Why? Because the k value of this one is how much? Is 2. The k value of this one is -1/2. And I multiply them. What is the answer if I multiply? Exactly that number that I need, -1. So yes, this line and that line are exactly perpendicular. So that was a non-trivial result that we discovered now. Is that understandable or not? Yes? So I would say that two lines are perpendicular even if and only if one of them is horizontal, the other one is vertical, or the product of the k values is -1. Let me ask you one thing. If L1, by the way, I want you to be quick in calculation. Assume that L1 is perpendicular to L2. I give you the k value for L1 to be 2. Can you immediately tell me what is this, the k value of this one?
-1/2.
-1/2. If I give you this is 2/3, what is this one? -3/2. So you need to reverse them and multiply by negative sign. If I give you it's minus the square root of 2 divided by 2, what is the other one?
2.
+2 over a square root of 2. So finding the other one would be very simple. Yes? So let us now solve some problems together. Yes? Okay, but there is one question I forgot to mention. What is the question? You should have a question now. Because what I showed is only for this case that the lines are passing through the origin.
Yes.
Is it guaranteed that the same relation holds if the lines are not passing through the origin? Because you see, this is a special case. I told you that let us draw them from the origin. But there is no guarantee for that. Let me, for example, I can have one line here, and I can have one line here. Yes? So let me clean this one and I ask you the same question. So I have a coordinate system here, and I have these two lines. None of them are passing through the origin. But this line is here, and this line is passing here, okay? They are perpendicular. I tell you that the k value of this one, so let me write, this is L1, this is L2. And I guarantee you that L1 is perpendicular to L2. Do you think still the same relation holds, or should I modify this a little bit? Because these two lines are not passing through the origin. This method was really sensitive to passing through the origin. Do you remember? I rotate about the origin, and then I ended up in the other one. So if I start doing rotation, if I want to rotate any point here about the origin, I have to connect this one to this one and rotate it 90 degrees, you know. I will end up not on this line. I want you to understand the same method that I was using here is not directly applicable to this case. So then there is a natural question. Is it holding for this case, or I should modify it a little bit for the new case? Yes, I saw your hand was first raised. Yes.
I don't think we need. I think it still holds, since the k value only describes the slope, or in other words, which is just another way of expressing the angle.
Mm-hmm.
Then and because k only describes angle, then we could change the m value to whatever we want, or in other words, we could parallel transport
Exactly.
to wherever we want.
Exactly. Is that understandable? So what we are saying is this. I can describe it a little bit differently. I go from here to the origin. I draw a line parallel to L1. So I draw this line parallel to L1. Okay? From the origin. So this means that, let me call this one L1, but I put a prime on it. It means it is similar to L1, but not L1. This is common in geometry. When you have similar points, you can, for example, call them A, B, C. The other ones A prime, B prime, C prime. And if you have the same... So I mean, I can completely change the letter to a different letter, but I would prefer to put a prime there. So they are more or less the same thing, drawn from different positions. Okay. Let me ask you one question. If I ask you, what is k value of L prime 1, you don't know. But what is the relation between the k value of this green line and the k value of this black line, L1?
Exactly the same.
They are the same because of the previous problem, yes? We learned that if two lines are parallel, k values are the same. So this means that the k value of L prime 1 is exactly equal to the k value of L1 because I myself drew a parallel line to L1. I do the same thing here for L2. I draw a line parallel to L2. You see, parallel to L2 from here. Okay? So yes, hopefully you agree with me. That is L2. But can you tell me what this angle is now? I call it L prime 2. What is this angle? What is this angle?
90.
90. Because this is parallel to this one. This is parallel to this one. The angle here where was 90, the angle remains 90. Yes? And now if I ask you, so what is the k values? K value of L prime 1 is equal to the k value of L prime 2 is equal to k value of L2. Then I multiply them side by side. This one multiplied by that, k of L1 prime multiplied by k L2 prime is equal to k of L1 dot k of L2. Because this number is equal to that, this number is equal to that. So if I multiply these numbers, it becomes equal to the product of these two numbers. But can I say this is minus 1 or not? The left-hand side is minus 1. Why? Because this one is the same problem that I convinced myself. These lines are perpendicular and passing through the origin. So according to the argument here, this is guaranteed that the k values here are multiplied to minus 1. And this one is supposed to be equal to this one, so this means that that is also equal to minus 1. Yes? So it doesn't matter. So that's a very, very nice relation. It doesn't matter where the lines are located. If they are perpendicular, that relation should hold between the k values. Any questions? Okay, let me write some examples here for you. Example. This is a simple one, but important one. So let me equip it with a star. Okay, I want you to understand what's going on. I want to write this example. Determine an equation for the line, I mean a straight line, that passes through the point, say A with coordinates minus 1 and 5, and is perpendicular to the line for example 3x minus 2y equals to 7. Okay, so that's a very simple problem. We solved similar problem for parallelness. Yes, I told you write an equation for a line that passes through a point parallel to other line. But now I'm asking more or less the same question. You're supposed to find an equation for a line that passes through a point, but this time perpendicular to another given line. Yes. Again, don't spend time to make a precise figure for yourself, because that's just a waste of time. Of course, if you want, there is no big deal to do that, but I don't want to spend so much time on it. I want to analyze the problem, understand it. So here, let us consider this solid line is this line. It might be completely wrong, but forget about it. Okay, so assume that this line is that one, and then you have a point somewhere here. And then what is your goal? Your goal is to draw a line that passes through this and is perpendicular to the given line. Yes? And this is what I do in a scratch paper quickly to analyze the problem and try to solve it. But that is up to you. If you want, you can use GeoGebra, for example, to draw a very precise figure, but don't depend on it so much. Because if you depend on these softwares a lot, then if you don't have those softwares, then you will be in trouble. Okay? So, how should I solve that problem? Because I am going to determine an equation for the straight line, I know that y minus y node equals to k x minus x node should be my formula. And I know that x node is this number, I know that y node is this number. What is left for me to understand is the k value of my line. So the k value of this one I want to find. Okay, how can I find that according to what we learned now?
First,
Yeah.
find the k value of the...
Sergey, let us Sergey answer that. Yes. Yes.
So I thought that you just find the k value of the equation,
Yes.
and then through the formula that we just learned, we find the k value of the perpendicular line.
Exactly. Exactly. So what I do, so this means that, so let me call this one k, and then let me call this one k prime, for example. The k prime is the k value of this line, but this is not in the k form, so I have to make y alone to be able to read the k value. So then I would start from here to make y alone. So I move 3x to the right, it becomes minus 3x plus 7. I make y alone by dividing by negative 2, so it becomes 3 over 2x minus 7 over 2. So this is exactly the same line, but it is in the k form. So if I ask you what the k value is, you immediately read it from the equation. And I called it k prime. So this is 3 over 2. But then, because these two lines are supposed to be perpendicular, just do it quickly in your head, according to the method that I told you. This number should be a number which is multiplied here, should give you minus 1. But do it quickly in your head. What's the answer? Change these two, and then provide a negative sign. That's minus 2 over 3. So then I have the k value, I will take it and put it here, and then I enter. So then it becomes y minus y node, which is 5, is the k value of the line that I am supposed to write, which I got it, x minus x node, which is minus minus 1, so let us just do it quickly, positive 1. And then let us simplify it a little bit. So it becomes minus 2/3 x minus 2/3, and then I move 5 to the right, it becomes positive 5. Then it becomes y equals to minus 2/3, and this one, if you do it in your head, what's the answer? No, you always make that mistake.
I didn't see the minus 1.
Yes. So it is 15 minus 2. It's 13 over 3.
Yes, so.
Yes? Is that right? So this is a simple example. I want to continue a little bit. This is the last session, so you will be happy by tomorrow, yes? So let us work a little bit more. I think we already talked about perpendicular bisector of a line segment, didn't we? Yes, so if I have a line segment, do you remember? Perpendicular bisector of a line segment. Okay, so what is that? Perpendicular bisector of a line segment. What is the meaning of this? You need to know that is a common term in geometry. Perpendicular bisector of a line segment. The name is on it, yes? It is bisecting the line segment and it is perpendicular to it. Yes? So what does it mean? It means that I need to find the midpoint. And from the midpoint, I draw a perpendicular straight line. Yes? So if I call this one M, midpoint, and so this means that this length is equal to this length, and if this angle is 90 degrees, this is called the perpendicular bisector. Yes? That is the perpendicular bisector. Do you think it makes sense to say perpendicular bisector of a straight line? It doesn't make sense because there is no midpoint for a straight line. Straight line goes to infinity from both sides. Where is the midpoint? We don't know. So it doesn't make sense if I say perpendicular bisector of a line. This is why I have to emphasize on line segments. But be careful. This perpendicular bisector by definition is not a line segment, it's a whole straight line. You might say why? That is just definition. People have defined it in that way. When I say perpendicular bisector, I mean the whole line. The whole orange line, not just a segment of it. Yes? Okay. The question is this. The question is that if I give you the coordinates of point A and B, the end points of the line segment, and I ask you to find an equation for the perpendicular bisector, now we can answer that question. Yes? So let me write an example. Let me write determine an equation for the perpendicular bisector of the line segment AB, where A, for example, has coordinates 2 and -5, and B has coordinates -6 and 3. Okay, I want to pause recording. This is a simple problem because now you understand what is the meaning of perpendicular bisector. I want to wait for you to solve that problem until the end, yes? Determine an equation for the perpendicular bisector of the line segment AB, where A is 2 and -5, B is -6 and 3. Analyze the problem and try to solve and answer it to me. Okay, thank you. I want to wait for you. Okay, what happened then? A lot of 30 seconds has passed now.
Det var det jag fick.
Y equals x plus 1?
I don't know, I have to calculate.
That's what I don't know.
Okay, but at least you can tell me the method. The details I can do it for you, even though you have to learn to do the details precise and quick. If you want to, of course, there is no rush here in Sweden. You don't need to be very fast, but I prefer to be fast. I think it's good for your brain as well. Okay, so what is your strategy?
Well, first I found k for the relying on AB.
Yes, so what is the point? The point, for example, if you consider this a rough picture of this scenario, I want to find a slope of this. I want to find an equation for the orange line.
Yes.
So then I have one formula, and that is 1-point formula, yes? Then I need to fill up these numbers. If I can fill up these numbers, I am done. Because I want to write an equation for this orange line. This is a straight line. An equation for this straight line is of this type. I need to know these three numbers. As soon as I have these three numbers, plug them in here, simplify it, that is the equation that I'm looking for. But here, first of all, let us understand, what is x node and y node in this case? Any point on this line will work. But can I find all of them? Yes?
You can find the midpoint.
Midpoint. Of course, if you give me this, that is also possible, but I don't know. According to the information given in the problem, this is the best that I can hope that I can find, yes? So this means that I know x sub m is x sub a plus x sub b divided by 2. Y sub m is equal to y sub a plus y sub b divided by 2. And they are given. X of a, I read it from the problem, it's 2. X of b is plus minus 6 divided by 2. So it is minus 2. And then here, y of a is given to be minus 5 plus 3 divided by 2. So it is minus 1. So this means that the point m, I know it now. It's minus 2 and minus 1. This will play the role of x node and y node. So I am done with that part at least. The only thing that I need to do is the k value. But today we learned that if I find the k value of AB, because this is perpendicular to this one, immediately using that rule I find the k value for the orange one. Yes? So let us calculate the k value of AB. This motivates you to calculate the k value of AB, and that is the difference between the y coordinates divided by the difference between the x coordinates. So y of A is given to be minus 5, minus y of B is minus 3, divided by x of A is 2, x of B is minus 6. And if I calculate the numerator is minus 8, this is 8, and then it becomes minus 1.
So they left you.
Okay? Now, can you tell me what is the k value of the perpendicular bisector? Let us write PB for perpendicular bisector. The k value of AB is this number. Can you tell me what is the number here? You need to imagine a number so that when it is multiplied by this, it gives you minus 1. So what that number is? 1, yes? I am asking you, give me a number so that when multiplied by the k value here, the answer becomes minus 1. Do you agree that 1 is the number? Because 1 times minus 1 is minus 1. Understandable for everyone? Yes or no?
Yes.
Okay. So that is the k value of perpendicular bisector. Put all these numbers back here. So then it becomes y minus y node, which is minus minus 1, is equal to k value x minus x node. And I think Oscar meant you did it correctly, I think. So it becomes y plus 1, and then it becomes x plus 2. Then I move this to the other side. Y exactly is the answer that Oscar actually mentioned. So that is y equals to x plus 1. Is that understandable? So you need to analyze the problem like this and then try to solve it. I don't know. I want to continue the lesson by another question. But I give you 5 minutes rest and then we continue, okay? Because I want to ask the other part of the problem question. I don't know if this is in the book or not. It will come in the book eventually, but might be a little bit further. But before finishing this, because this is more or less, this chapter is finished now. So immediately after coming back, I give you a little bit of time to practice and we will have the first test on chapter 2, on math 2. But let me give you 5 minutes, okay? Now it becomes 4 minutes. Okay, so let us go back to the lesson. This is something I want you to know, okay? I give you 2 lines. First of all, before going to GeoGebra and draw it, do you think that these lines actually intersect or not? I have given you 2 lines, y equals to x plus 5, and the other one 3x plus 9, y equals to 3x plus 9. Do you think they will intersect or not?
Yes.
Why?
Because they're not
Parallel. Because k values are different, so they are not parallel. And if you do not have parallel lines in the plane, because you know that in a space we can have this situation as well. If you are allowed to work in a space, then I can have a line in this room and I can have another line in this room. They will never intersect, but they are not parallel. That's called skew parallel. The skew parallel, yes. But this does not happen if I am on a plane. On a plane, the lines are either parallel, if I am on the desk, or they intersect, or they overlap. We don't have any other situation, yes? Okay, so definitely the answer is correct. You told me that the k values are different because I am on the line, I'm on the plane, the k values are different, so they are not parallel. And of course you see that they are not identical, so this means that what? They have to intersect. Now the question is that, and you know that in GeoGebra there is a tool that you use to find the intersection point of figures. So, but if I want to do it analytically, in other words, how GeoGebra knows what the number is, what are the coordinates of the point of intersection, how we can find that point systematically. Just give me the idea. How can I find the intersection point? The coordinates of the intersection point of 2 lines. Using algebra. Pardon?
What?
You said something?
No, I'm just speaking to myself.
Okay. So let me go to a scratch paper. I don't know if the line, I don't want to be precise, but I don't need to. I have a line. I have another line. They intersect. For example, there are 2, let us call it point A, and then there are 2 question marks. I want to find these 2 question marks. Yes?
The y has to be the same number, right? The y has
Yeah, exactly. So that's the point. This is an extremely important concept. You shouldn't miss that. I told you that. How do you understand that the point is on a line or not? You replace x and y with the x and y coordinates. If the equation satisfies, the answer is yes. That point lies on the line. Yes? And if it's not, no. But here, I am looking for 2 numbers. Let me call this one x, let me call this one y. I am looking for them. This point is on this line, so it means that the coordinates should satisfy the equation of the first line. Yes? And now, this is also on the second line, because that's an intersection point. So the coordinates should satisfy the second equation as well. And this means that I have to solve them simultaneously. We will discuss these problems later. This is a system of equations, but I'm sure that in Grundskolan you have already studied how to solve system of equations as simple as that. This is not important. The important thing is that to understand why, if I solve this system and I get x and y, those x and y are the coordinates of the intersection point. That is what I want you to understand. Did you understand that part? Yes? So for example, if you don't like it, I can call them A and B. I don't know what are A and B. But I know that this point is on this line. So it means that if I go to the equation of the line, replace y with y coordinate, replace x with x coordinate, this is true. And if I do the same thing for this line, I will go here, replace y with b, replace x with a. This is also true. Yes? So I'm asking myself, I need a number a and a number b so that satisfies this and that simultaneously. But instead of bringing in a and b, I just work with x and y. If you want to, this is the real way of doing it. I hope that this is not... I myself prefer to work with x and y, because then I don't need to introduce a and b. Of course, that's up to you. So that means that I have to find two numbers, x and y, or in this say, a and b, so that this is true and this is true as well. And this is very easy. How can I solve this problem? Y and that y are supposed to be the same y. Okay? So instead of this y, I put this y. Because they are equal. Instead of this y, I put x plus 5 equals to 3x plus 9. Then I move 3x to the left, minus 2x. I move 5 to the right, it becomes 4. And then I'm looking for x becomes negative 2. It doesn't matter, I choose this one or that one. And put my x equals to minus 2 in there. So what happens here? If I put minus 2 there, it becomes 3. You see, it doesn't matter. If I put it here, I will get the same number. 3 times minus 2 is minus 6, plus 9 is again 3. So these question marks that I was asking, one of them is minus 2, the other one is 3. Yes? So whenever you want to find the intersection point, you need to understand why this is working. This is important. Of course, you can memorize. Whenever you want to find the intersection point, do this. That's not good. I want you to understand why this algebra is the same thing as geometry there. This I want you to understand. And then the rest of it is calculations, yes? Is that clear now? Okay. Now, I want to write a problem. I don't want to finalize it. But I want you to think about it. If I give you the coordinates of a triangle, how can you find the area of that triangle? Exactly. So my question is that I give you yes, A, B, C. A has two coordinates, XA, YA. B has two coordinates, XB and YB. C has two coordinates, XC and YC. Assume that I give you all these 6 numbers. And I ask you, find the area of the triangle exactly. This, in principle, you have enough knowledge to solve it. Yes? Because there are some, of course, there are some special cases you can answer immediately. You know, for example, if my triangle is like this, if this line is horizontal, then it is easy. Why? Because, of course, I can use the distance formula to find this. And then the point is that, how can I find the height? Because if I can find the height, let us call it h, then I am done. Because I use the distance formula and measure and calculate the length of BC. If I can find some way the height, then I take that number, multiply it by the BC that I got, and divide it by 2, that becomes my area. This is, I want you to understand, you tell me, how can I find h, little h, the height? In this case, it is easy. Because, for example, if I give you that, if I give you this horizontal, and it is 3, and if I give you a is 5 and 7, what is the height here? Can you tell me? By these numbers. If that is horizontal.
4.
So the height is 4, yes? So this is easy. But if none of these lines are parallel to the coordinate axes, then that would be a nice problem. So the whole point is to find the height. Yes, Haya, do you want to say something?
Oh, I had a suggestion.
Yes?
So we can find the point where H meets BC.
How?
Because what we just did there, the point of intersection.
Yeah, very good. Yeah, thank you. That's the idea. So what Haya is mentioning is, okay, we want to find this H. Because if I find this H, you told me that A is given, I use the distance formula and I am done. That would be H. Okay, let us discuss about this. How can I find this H? According to this problem, if I can find an equation for this line, an equation for this line, when I intersect them, it becomes this point. And this is doable. Why? Because if you give me B and C, I can find the K value of BC, and then I can find the K value of this line, because they are perpendicular. And K value is given, this value is also given, and then I can find this line. And then I solve the system. It is very lengthy, not very, but it is lengthy, but it is doable. The point is that now you understand. I don't want to solve it. I just give you these numbers and leave it as an exercise. Whenever you have time during the break, you can do that, okay? So let me go to the, yes, so I want you to do this. Yeah, so let me just write it here. So let me give you numbers. A to be 2 and 3, and then let me write B to be minus 2 and 4. Let me make it 5, and C so let me make it a minus, let me make it 0 and negative 3. Yes? So hopefully this is not one of those special cases, because if they are special, so I can check it immediately. So 2 and 3, 2 and 3 is somewhere here. And then minus 2 and 5, somewhere here. This is A, this is B, and C is here. Yeah, I think this is good. Yes? Yeah. We want to find an area of that triangle. So try to find the number exactly at the end. And by the way, you can also check it using GeoGebra. And that's also good to learn. Yeah, let me just show that to you. So 2 and 3, can you memorize that? 2 and 3 minus 2 and 5, 3 and 0? 0 and 5. I'm counting on your memory, okay? 2 and 3 minus 2 and 5, 0 and minus 3, yes? Okay, so what was that? Can you tell me what are the points? A was what?
2, 3.
2 and 3 here. 2 minus, no, minus 2 and 5, yes? Minus 2 and 5 here. And the other one was 0 and minus 3, yes? 0 and minus 3 here, yes? And now let me do this one, you see. I take the polygon and I draw A to B to C to A back again. So that is my triangle. I want to find the exact value for the area of this triangle. There is a feature on GeoGebra that you can calculate areas, but of course it gives you to some decimal points that I have already adjusted for my system. Where is that, do you know? There should be somewhere. Okay, area. So you go and choose the area here, and then you click on it. So the area is exactly 14, by the way. That's a very nice number. So it means that just do it at home. You should be able to find the area of this triangle to be exactly. So that was a very lucky example. I just randomly chose the points. The problem is very nice. So the area apparently is exactly 14 area units. But you should be able now, of course, if you are a little bit creative, you might find another better way to do it. Please think about that one as well. So it means, in principle, you don't need analytic geometry for that. In this case, you can also solve it a different way, using geometry. But I want you to learn analytic geometry, so try to do it exactly as I did, as I told you. So and then you don't need to take. So you see, you can take this one to be your base, AC, or you can take this one to be your base, or you can take this one to be your base. But then, of course, if you take AC to be your base, the height will be somewhere outside because I have to continue. But it doesn't matter. The good point is that algebra is not that sensitive about the locations and things like that. Okay? This is one exercise that I leave for you. The next session that we meet together, this is the first thing that I want to solve. Because if we can solve this problem, this is one problem combining a lot of ideas into one single problem. And that would be a good idea to have a reading. Okay, thank you very much.